Hey everybody, welcome to episode 6. So we're going to mount the transformer here, and I want to show you how I'm going to make that hole bigger. And I was going to try to use one of them step bits or those tree bits. And I thought about it, and I've got this bakelite block right here, and I really don't want to start messing around with things under there. So what I'm going to use is a Greenlee knockout punch. I don't know if any of you have ever seen one of these things before, but basically they're great for making holes in a chassis. Here's the kit here. Let's see if we can pull that shot back a little bit. And there's a couple of sizes in here. There's obviously a really large one, 1¼ inch, and I believe that's an inch, and this is 3/4, and then this is 1/2 inch, and this is the one that we're going to use as 1/2 inch. So I will show you how to use it in case you've never used one before, and they're really handy. So there's 3 pieces. There's a bolt, there's this cup, and then there's the actual die. So in order to use this, you slip the cup over the bolt, so there's a space here, and you put it in the hole like that. And then we're going to flip this up. I'm going to take a look underneath and make sure we have room. I want you to be able to see all this. So you notice I've loosened up this bakelite block here, and let's move that cap out of the way. And then all you have to do is just thread this on here like this. Now by doing this, I know that there's nothing that's going to get destroyed under there when I tighten it. So we're just going to tighten that down until it gets snug, like so. And it's just about there. A little bit more to go. Okay, it's snug. So looking at this very closely so you can see it, there's the die, there's the bakelite block, there's nothing in the way, there's no wires. All we really need to do now is take a socket wrench and tighten this bolt right here, and keep tightening it until that cuts that hole, that circle out. And they really do a great job. So let me get my my socket set here, and we'll go through it. Okay, I just realized I don't have a socket big enough for this, so we'll have to fix that. So what we're going to use is this adjustable wrench, and all it really takes is just turn. Now before we go any further, I want to make sure this thing is pushed in all the way. I don't want to make a hole in the chassis, okay? So I want it to be almost perpendicular with the edge here. So let's get to it. I'm just going to make some turns, like so. And you'll know when it's done. It'll pop, and this thing will get really easy to turn. I can feel it cutting. This metal is relatively soft, so it should be done in probably 2 more turns. I just heard something. It's getting a little tougher. That means we're getting to the end. Did you hear that pop? That means one side broke through. There it is. See how easy that turns now? Look. Pull that out. The hole's bigger. And the piece of metal that we removed will be inside here. So let's take that out, and you can see it. It'll be split in 2. That's the way this thing works. And all I really have to do now is file that hole, make sure there's no sharp edges on it so the wire doesn't get crimped or cut, the insulation. We don't want that. Here, be right back. Okay. This little sucker's stubborn. There it is. Okay. And here's the pieces that it cut out. Right? Nice and smooth. And that's how these things work. much easier than using a step bit. And there's very little sharp edge here. I just have a little bit right here, which I'll have to file. But now our wires will fit down there without any problem, and it doesn't destroy the footprint of the chassis. It actually fits within the parameters of where the original transformer was. We didn't have to do anything here. Okay? So now I'll drill the holes and we'll mount this thing. While I'm demonstrating stuff, I might as well show you this deburring tool. I don't know if you've ever seen one of these. It's basically got a little bit of a blade here, and it rotates. And when you do a thing like this, all you do is you just go like this. You just scrape the inside out. Gets rid of all the sharp edges. Obviously you got to be careful if you've got components under there. But it does a fine job here. We got one little spot right here. There you go. It's a deburring tool. This one's made by, let's see, doesn't tell you. It just says approved for automotive. You can find these on Amazon. That's where I got this one. Be back. Okay, we've drilled our holes. We've also put a rubber grommet in here, and we'll see how that works. I may have to take that out because the transformer may not sit flush. I have to have spacers there. We'll see. I'll let you know. Okay, our transformer's mounted. We're good to go here. Certainly makes the radio heavier. It's definitely heavier than the one that was there. So here's all the wires that we're going to have to reconnect. And I did make a mistake earlier about the filament for the heater. For the rectifier tube. It is not a 5-volt rectifier tube. It's a 6.3-volt rectifier tube. And it's a 7V4, if I am remembering this correctly. And they did not step the voltage down, so that's why they got away with a transformer in here that only had 6.3. We are still going to use the 5-volt rail. That will be plenty to heat up the tube. I've checked with Brendan on that. So we're going to continue with our plan there. So we are going to use this yellow pair to do that. And the green pair is a 6.3 volt winding. And you'll notice on this transformer I did use standard color codes. That's not the way Philco did it. The way Philco did it on this one, let's see, the primaries were white, the 6.3 volt filament was black, the rectifier filament was blue, and the high power was yellow. So I've made these more standard, so I'm using red. Here's my center tap. I've got some blue stripes on there. And we're good to go. So let's get this wired and let's test this thing out, this sucker. All right, be back. Okay, in the process of connecting the transformer, I wanted to just document this more for myself and see if it helps you. This is our rectifier tube, and the way this radio was wired, first of all, I made an incorrect statement earlier about the filament line for the rectifier. I think I put this in the earlier part of the video, so if I did, I'll just cut this out. But essentially, it's using a 6.3 volt line just like everything else. We're going to put the 5 volt winding here for the rectifier tube, and it'll work just fine. So what I've done here is I've removed all the connections to this rectifier tube, and a couple of notable things. One is the dial light was connected here, so we need to move that over to the other tube. And also, there was connections that went back to the other filament string, so we need to clear that up, obviously. So we've got this thing now in decent shape. I'm going to have to take this cap out and redo it. I don't like it. It looks like crap. Now that I'm doing this right, I'm going to do it right. And we're going to connect our high power here to pin 3, 1, 2, 3, which is right here. And then the other side of the high power lead comes over here to this terminal strip, right in here. Right here. I'm going to clean that up because that's a big ball of mess. And then our center tap comes over here as well. So I think we're going to be in very decent shape here, getting this thing connected. And then our filament string will be independent. So the 6.3 line will start on this socket and work its way back into the dial light, and the 5 volt line will be here. All right, we've already got one filament string tied to ground, which is required. We've got our power, our primary connected already, one here, and the other one goes here to a terminal strip, which also comes up to the front and goes to the power switch. That's done already. And we're plugging along here. So I'll come back when this is all done. Just wanted to document that we're doing a little bit of surgery here on the rectifier tube, and I'll actually modify the drawing and show it to you when we get done, so you can see what I did. So if you ever have to convert something like this, you'll know what to do. Shall be back. Okay, our transformer is all wired in with one exception. I don't have the center tap of the high power side connected to the radio yet. And the reason why is because this transformer, as I said earlier, is a little bit more power than the original one. The original one had around 550 volts AC coming out of the high power side. This one has about 620 or 30. So I'm going to need to put a resistor in for B+, because it's going to be way too high. If you look at the schematic right here, let's zoom in on there, and you'll see that we're going to be looking for right here. I'll point that out for you. Why is this thing shaking so much? I got to look into that. Anyway, what we're looking for here is 285 volts right there. That's where my B+ comes in. Why is this camera shaking? Anyway, we're going to be looking for 285 volts here. So I'm going to do a power up with just the rectifier tube in, and we're going to throw a meter on there and see what we're getting out of it. And then we'll put a decade box on there and find the right value of resistor to get it down to 285. So that's going to be the plan, and we're going to do that. I've also ohmed out all the filament connections. So right now the rectifier tube, which is right here in this corner, is independent of the rest of the tubes. Right, it was all one big string before. So we've isolated the filament string here for the rectifier. We've got the 5-volt line there. And then we've got the 6.3 volt connection going out to the lamps and everything else, and that's all worked. I've isolated it. I've done testing to make sure there's no problems, and we're good. So all that's really left to do now is put it on a dim bulb tester. Let's check the, let's throw that rectifier tube in, make sure it's heating up, and we'll see if we get anything out of here. And then once we know what that is, we'll pop a resistor, and this is where it connects right here. We'll zoom in so you can see it. This is our B+ connection right here, this wire. All right, it goes down to this terminal strip, which I've got to clean up. So we're going to figure out what we need to put in there. All right, we'll be back when that's been figured out. Well, here it is 2 weeks later. Today is August the 6th. That previous segment you just watched, I recorded on July 16th. So where's Ron been? Ron's been on vacation. Ron's been away. And Ron's been busy when he got back working. So just to keep you up to date here, so that last segment we said that we were going to put this thing on a dim bulb tester and test it. So we did that, and we got some mixed results. So I didn't record any of it because I was troubleshooting. So we were able to get the tubes to light up, no problem. We were able to get the radio to work essentially, except that all we heard was a really loud 60-cycle hum. So that prompted me to go through this entire power section, and the reason why I knew it was the power section, for two reasons. One, the volume had no bearing. That's the first clue that I had that there was no issue with the radio itself, that it has to be in the power supply section. And then the definitive test that proved it to me that was in the power supply section is I was able to remove the 7C6 tube from the radio. And if we look at our documentation, that's our audio, or our second detector, our AVC tube. We removed that from the radio and turned it on, and we still had a hum. So that tells us that that the power supply section was the problem. Okay, great. So I went through the entire radio and looked at all the connections and made sure that everything was good. I made sure that my filaments were twisted and tied down correctly. Still couldn't get rid of the hum. So what I did is I took the power cord, and I've removed it now, so it's not on the radio, and I put a lead of my voltmeter on one blade of the power cord and to the chassis, and I got continuity. And then I did the same thing with the second blade, and I got continuity. And of course the ground, I got continuity, you're supposed to. But I'm not supposed to be getting AC to the chassis. That's no bueno. Right, that's bad. So what I ended up doing is removing the transformer from the radio And I checked all the individual windings, and they were all good, nothing open, okay? But then I did a check across the 6.3, excuse me, the 6.3 volt filament winding and the primary, and I got a reading. That should not be the case. There should be no reading there. So that tells me that the transformer that we put in here had a problem. There's probably something inside there that's not right. I wasn't able to detect it when I was testing it because all the windings were good. So that transformer is out of the radio. It's gone, in the garbage. It was an old Philco, if you recall, from a Philco 84. It's in the garbage. And what I was able to do is get a replacement transformer for this. It's a Hammond, and I believe it's a 290p DAX, I believe it is what it is. I have to look that up. I'll post it on the screen if I have it wrong. And essentially what that is 560 volts center tapped, which is what we need. This radio calls for 54 milliamps. This one is 60, so it's perfect. It only has a 6.3 volt filament winding at 3.5 amps. This one was 3 amps, so we're good. And it's got a very small footprint, so it'll mount right on the top here just like the other one did. That will be here Thursday. And once that gets in, we'll put it in the radio and wire this thing up, and I'm sure it's going to work. I actually was able to hear a very faint station through that 60 cycle hum, but you couldn't hear anything. So once we get our transformer in, we'll be ready to rock on this thing, I think. And we'll have that in the next episode and prove that that worked. So the moral of the story here is, even though you test the windings on a transformer, you have to check across the windings too, which I didn't do. I probably should have just put the transformer on a variac and tested it. If I would have plugged this thing into the wall, I would have either blown the transformer up even further or popped the circuit breaker, right? So that's why we use a dim bulb tester, although in this case the dim bulb tester didn't show me that there was a leakage between the windings. So it's not all that uncommon, but it happened, and that's okay. So we're going to get this radio, which I'm calling, by the way, number 41. And I'll tell you a little story about this radio and the one I'm going to work on next. So this is, of course, my Philco 41-245. The reason why I chose this radio was because of the year that it was made, 1941, which is the same year that my mom was born. All right? My mom died in 1988 of lung cancer at the age of 46. So this radio is dedicated to her. And the second radio I have is the RCA with the green eye tube, and that's a 1939. And that's the year my dad was born. And of course, my dad still lives here, very close to me, nearby here in Jacksonville, Florida. And I told him that radio is going to be dedicated for him. So of course, we're working on mom first. Women first. That's what they say. So this one's going to be dedicated to mom when it's done. And the second one will be dedicated to dad when it's done. And I'll have number 41 and number 39. That's what we're going to call them. So I've got a dead battery here, so let's change it. Okay, of course we had a dead battery. So what we're going to do is we're going to wrap up this episode, and when the transformer comes in, we're going to pop that in, and then we will fire up the next episode and hopefully wrap this radio up. All that's going to be left to do is reinstall the rest of the parts. Right, we've got this push button control that we need to connect, and you'll see it's all cleaned and ready to go. Just need to change these wires. And then we've got the tuning dial that has to go on, and all that stuff. And I don't remember if I showed you this or not, but it's been cleaned up, so it's been shined up real nice. This is the tuning where the tuning dial goes. So we'll be ready to go. Just a question of getting the radio working. So anyway, that's going to be it for this episode. We're going to upload it. It'll be one of my shorter ones, and in the next episode, you will see this radio work. We're also going to be working on on our bass pedal. That I worked with, designed with Brendan, and we're going to be building that as well, and that'll be coming up in an upcoming odds and sods video. So anyway, I hope everybody's well. I've been away for a bit. I'm sorry about that. If I haven't caught up on your videos, I'll do my best. And until then, I will see you guys later.